So now, we are going to discuss about unit number 4, that is a state machine. So what is there in this unit? Okay, so let us see the contents of this uh, topic, that is state machine using Murray and Mealy model. So I think in a digital techniques, you must be aware about what is mean by state machine, what are the different types of state machine. That is the Murray model and Mealy model. Okay, so you have just at least a basic idea about what is mean by state machine. Okay, already we have conducted one guest lecture session on this topic, but now here actually we are going to discuss about our complete. Hello, am I audible?
Yes, ma'am.
आधीच ऐकायला येत होतं?
नाही, ma'am.
Okay. Actually, I'm using two systems for this, one for presenting and another for talking. So I lost connection there, okay, which I'm using for discussing purpose. Okay. So once again, I will tell you that we are going to discuss about the state machines in this unit. So state machine using Murray and Murray model. So that is the basic thing that we are going to discuss. Then VHDL model using state machine for sequence detector. Then traffic light controller, coffee vending machine, multiplier using add and shift method. So these are the contents that we are going to discuss in this unit. So write down these contents and then reference book, that is circuit design and simulation using VHDL by Volney Pedroni. and another book that is a digital design principles and practices by John Walkerly. So these are the two books. Besides that, we can use any digital design principle book for basic idea about state machines, and then this VHD Pedroni book that will be useful for you to get the concept regarding VHDL code. Okay. So once you finish this writing, we will proceed. Now is it now? Is it coming?
Yes, ma'am.
Oh, कधीपासून येत नाहीये आवाज? की काहीच नाही ऐकायला आलं?
काहीच नाही आलं मॅम. आम्ही नुसतं लिहून घेतोय.
You should have told me earlier.
मॅम
अरे
मला वाटलं की ते लिहायचंय म्हणून आम्ही लिहूनच घेतोय.
ओके ओके ठीक आहे. पण ओके तुमचं लिहून झालंय ना?
मॅम फार फास्ट स्लाइड बदललेत मी. एस काढून घेतलेत मी लिहीन.
ओके ओके ठीक आहे. आय एम गोइंग टू शेअर दिस विथ यू सो दॅट यू कॅन राईट इट. काही प्रॉब्लेम नाही येणार. पण जर माझ्याकडून आवाज वगैरेचा काही प्रॉब्लेम आला तर जस्ट लगेच मला सांगा. म्हणजे ऍटलिस्ट मेसेज करा म्हणजे मला लक्षात येईल. ओके. मी बऱ्याचदा आज ऍक्च्युली माझ्या मोबाईल मधून मी लॉग आउट होतीये, मीटिंग मधून आउट होतीये. सो लगेच मला कळू देत सो दॅट आय कॅन रिजॉईन अगेन. ठीक आहे. Maybe there is a network issue. Okay. Now, so what is mean by HSL? So this was my question actually. I think you have studied this. Okay, little part of this you have studied in digital techniques. What idea you have about state machines? I would like to hear from you, and then we will continue. Actually, state machine, that is the way to represent any sequential circuit. Okay, so that how we are going to get the output depending on input as well as the state of that circuitry or that machine. Okay, so that what will be the next state that we are going to decide using representing that application or that circuit in certain manner. That is the state of machine. Now, a finite state machine, that is based on idea of there being a finite number of states for a given system. Now, whenever you are considering any system, that time it will have certain finite states. Okay, and on this idea only, this state machine is based. Now, for example, you have any application which turns on a LED. So that means it is turning on the LED and turning off. Okay, so it will have two states. One is LED is on and another one, that is a LED is off. Okay, so these are the two states for that application. Now, whenever you are, suppose you have a certain switch, you are turning on that switch so that LED will be on. Okay, so that means you are giving input high and then you are making that LED to be on. So this will be the first state depending on the your input. Okay. Now you are making again that switch off so that the earlier state was on for the LED. Now it is going to be off. So this is the another state of that application. Okay, so that means that this application is having two states. One is on, another one that is a off state. Now suppose that we have similar type of application, but now we have 8 LEDs. Okay, and we want to turn on these LEDs sequentially. That means first of all we want to make whenever we are going to switch on, that time first LED should be glowed. Okay, after that it should be off. Then for the next input, that time second LED should be gone on. Thus it should happen in sequential manner. Okay, now it is required that now again we want only one LED to be on at a time. Okay, all other LEDs that should be in a off condition. That means we will have 8 different states for that application. ओके. मगाच्या ऍप्लिकेशन मध्ये म्हणजे जेव्हा एकच एलईडी होता तेव्हा काय असणार आहे, एक तर तो ऑन असेल किंवा ऑफ असेल. पण जर माझ्याकडे 8 एलईडीज आहेत आणि त्या जर मी ऑन करतेय सिक्वेन्शियल मॅनर मध्ये, तर काय असणार आहे की प्रत्येक एलईडी हा एकदाच ऑन असणार आहे आणि बाकीचे त्यावेळेस ऑफ असणार आहेत. म्हणजे माझ्याकडे 8 डिफरंट स्टेट्स असतील. ओके. And this each state that consists of one LED being turned on while all the others are in a off condition. So that is a model. Okay. Now we can represent this model in a certain uh, that means in a state machine. Okay. So here we have these 8 states, and now how we are going to get the output, so that can be represented. So that is the state machine. Now, this state machine that requires a state variable that we call as a SV, or that we abbreviate it as a SV. So this SV is essentially a pointer that keeps track of the state that the microcontroller is in. Okay. So whatever state that microcontroller is, which you are using for your application, and then it directs the program flow to the corresponding software module. Okay. So this state variable, that is a very important pointer, so that you will get idea how your output is going to be there. Okay. The state variable can be modified in the more software modules themselves or by outside function. So if you want to modify this state vector, then that you can do in a software module also, or you can do it from the outside function. That means from the inputs that you or logic function that you can build externally, and then from that also you can change the state variable. The example firmware uses an outside function which detects a button press to advance through the states. Okay, now here, whatever example that we have considered. Okay, so here there is an outside function. Okay, so what we are going to do, this state variable that we are going to change depending on the button press. Okay, so if we are pressing the button, so then that output is going to change its state. Okay, so that means there will be state change, and then uh, we are going to do this for all the state changes. Okay, so as our application will have 8 states, so for that we are going to use this outside function. Okay, now this state machine, okay, what is it? Okay, you can see this is the diagram. Okay, so this is the basic diagram that we have for the state machine. Okay, so what is it? It uses inputs from the environment, and then it will have a next state logic. Okay, so what will be the next step? That will be decided with certain logic. Okay, at the same time we will have the input from the state variable. Okay, so this state variable as well as the inputs from environment. Okay, so whatever may be that input, so that will decide what is the next state. Okay, now this next state that is again going to decide what will be the state variable, next state variable. Okay, so for the next state, and again from that we are going to decide the outputs. Okay, so these are the outputs to the environment. That means whatever application तुमचं जे काही application आहे त्याचे outputs decide होतील. कशावरून decide होतात, तर या state variable आणि तुमचं जे काही logic आहे त्याच्यावरती depend. Okay, so this is the basic concept regarding the state machine. Okay. Now what are the advantages of state machine? Okay, the first advantage is that state machine is inherently promotes good design technique. So this is the very important and the first advantage of state machine, that you will get a very good design technique when you are using a state model. When beginning to implement an application, think about what states are necessary to make the application work. Okay, uh, you can consider any application and then think about that what were the different states that are going to be present in that application. ते तुम्ही कुठलंही ऍप्लिकेशन घेतलं म्हणजे तुम्हाला समजा काहीतरी डिझाईन करायचे. ओके, सो सपोज यू आर गोइंग टू हेल्थ मॉनिटर और हेल्थ मॉनिटरिंग प्रोडक्ट यू आर डिझाईनिंग. ओके, त्याच्यामध्ये तुम्ही काय करताय की तुम्ही समजा टेम्परेचर मॉनिटर करता, तुम्ही पल्स रेट मॉनिटर करता. ओके, एवढे सगळे स्टेप्स तुम्ही मॉनिटर करता. तर तुम्ही जेव्हा हे ऍप्लिकेशन बघाल तेव्हा तुम्ही काय कराल पहिल्यांदा की त्याच्यामध्ये कुठल्या वेगळ्या वेगळ्या स्टेट्स असणार आहेत दॅट यू आर गोइंग टू decide. Okay, so that will be the first task that you are going to do whenever you are going to get your state model, and then you are going to list all the pieces or states of the application and then explore how they are going to tie to one another. So because of that, this will help to prevent developing bugs in the code. Okay. So whenever you are going to write any code, okay. So now this is whatever I am discussing now. This is in general. Okay. This you can use for any software technique. Here we are going to do this for the VLSI technique. Okay. So how we are going to use this for the VLSI circuits that we are going to discuss. But this is helpful for any code that you are going to write. ओके. सो जेव्हा जेव्हा तुम्ही कुठलंही ऍप्लिकेशन घ्याल तेव्हा त्याच्यामध्ये कुठल्या वेगळ्या वेगळ्या स्टेट्स असतील त्याआधी एक तर तुम्हाला डगआउट करावे लागतील आणि ते केल्यानंतर त्यानंतर तुम्ही एकमेकांना कशा टाय करणार आहात आणि त्यानंतर तुमचं ऍप्लिकेशन कसं वर्क होणार आहे दॅट यू आर गोइंग टू डिसाइड. म्हणजे हे तुमच्या समोर एखाद्या चार्ट प्रमाणे असेल किंवा एखाद्या मॉडेल प्रमाणे असेल किंवा तुम्ही स्टेट मशीन ड्रॉ करता ते आणि त्याच्यावरून तुमच्या लक्षात येईल की माझं सर्किट असं असं वर्क होणार आहे आणि मग मला आउटपुट मिळणार आहे. ओके. अँड देन माय आउटपुट प्रत्येक स्टेट नंतर माझं आउटपुट काय असणार आहे ते तुमच्या लक्षात येईल. म्हणजे जर मी सिंगल एलईडीज फक्त कन्सिडर करत असेल तर माझं काय मी बटन प्रेस केला तर मला ऑन व्हायला पाहिजे. ऑन असलेला एलईडी जर मी बटन परत एकदा प्रेस करते तर तो ऑफ व्हायला पाहिजे. ओके. म्हणजे मी जर तो बटन ऑफ करते तर ऑफ व्हायला पाहिजे. ऑफ असेल तर तो ऑफच राहील. बरोबर आहे ना. तर मला असंच वर्क व्हायला पाहिजे की माझं जर एलईडी ऑफ आहे जरी मी ऑफ स्विच ऑन प्रेस करते तर तो ऑफ राहायला पाहिजे. मी जर ऑन स्विच करते तर तो ऑन झाला पाहिजे. आणि ऑन स्विच जेव्हा असताना जर मी परत तो ऑनच करत असेल तर तो ऑन राहील अदरवाईज तो ऑफ जाणार आहे. ओके. सो इन दॅट वे आय एम गोइंग टू डिसाइड my circuit will work. Okay. And then because of this I can prevent, okay, or I can reduce bugs in code. Okay. So जो काही flaws असतील तुमच्या कोड मधले that you can reduce by using this type of model. So this line of thinking also leads to the development of a very engineering tool that is a flowchart. As you know that flowchart, this is a very useful engineering tool. म्हणजे तुम्ही कुठलाही कोड लिहित असाल तर त्याच्यासाठी तुम्हाला काय लागतो फ्लोचार्ट लागतो. ओके. आणि त्याच्यासाठी तुम्हाला स्टेट मॉडेल युजफुल ठरेल. म्हणजे जर तुम्ही कुठलाही कोड लिहिता आणि खूप मोठं ऍप्लिकेशन आहे तर तुमच्याकडे अशा टाईपचा जर चार्ट असेल तर मॉडेल असेल तुमच्याकडे तर तुमच्यासाठी फ्लोचार्ट ड्रॉ करणं दॅट विल बी व्हेरी इझी. So that is the benefit of this. Okay. Now, this state machine programs that have one characteristic that cause them to be very beneficial. This all and that characteristic is that this always return to one spot, okay, or at jump station in the code at which the program flow is channeled by the state variable to the corresponding software model. Okay. म्हणजे इथे काय होतं की जेव्हा जेव्हा तुम्ही तुमचा कोड रन करताय किंवा काही करताय तर तो एका पर्टिक्युलर पोझिशनला रिटर्न येईल. ओके. जिथे तुम्ही तो त्याला त्या फ्लोला चॅनल केला. ओके. म्हणजे जसं तुम्हाला फ्लो व्हायला पाहिजे त्याचप्रमाणे तो रिटर्न येईल. ओके. सो दिस इज द व्हेरी इम्पॉर्टंट कॅरेक्टरिस्टिक ऑफ द state machine. This characteristic makes calling repetitive tasks on a regular basis quite simple. That means clearing the watchdog timer, checking the IO button presses, or communicating with a host that requires periodic communications are examples of repetitive tasks. So, the alternative to using state machine is to looping code. So that is the alternative. But in order for looping code to handle repetitive tasks, the functions that handle these tasks must be distributed throughout the code in each of the loop. And this is not very highly inefficient, but also confusing to understand. Okay. So here you can see in this diagram the लूपिंग स्ट्रक्चर. ओके, म्हणजे मगाशी आपण जे ऍप्लिकेशन बघितलं की मला 8 LED सिक्वेन्शियली ड्रॉ ऑन करायचे आहे, तर त्याच्यासाठीचं माझं जे काही लूपिंग मॉडेल असेल ते ह्या प्रकारचं दिसेल. ओके, सो दिस इज लिटिल बिट कन्फ्युजिंग. म्हणजे इथे तुम्हाला काय करायला लागेल की मला पहिल्यांदा इनिशियलाइज, यू हॅव टू इनिशियलाइज फर्स्ट ऑफ ऑल रूटीन, then clear watchdog timer, and then you have to check for whether there is a button press or not. Okay, if button is pressed, then turn on LED 0. Okay, if no, then again you have to go for the clear watchdog timer, and then wait for till button press is there. If button press is there first time, then again you go need to check for the whether there is a second button press is there or not, and in that way you have to wait for these 8 times button. ओके, म्हणजे एवढ्या वेळेला तुम्हाला चेक करावं लागेल, अँड दॅट इज लिटिल बिट कन्फ्युजिंग. सो इन केस ऑफ दॅट यू कॅन हॅव अ स्टेट मशीन. तुम्ही जिथे फक्त एवढंच म्हणू शकता की माझ्याकडे 2 स्टेट आहेत, एक तर बटन प्रेस केलं आणि एक तर नाही केलं. ओके, सो इफ बटन इज प्रेस, देन आय कॅन टर्न ऑन LED ऑन, or if button is not pressed, then LED will be in off condition. Okay, so this only you can have for the state machine. म्हणजे हे प्रत्येक तुम्हाला कुठल्याही ऍप्लिकेशन साठी हे तुम्हाला युजफुल पडेल की तुम्ही जर असं मॉडेल ड्रॉ केलं तर. ओके, सो नाव ऍक्च्युअली दिस वॉज अ व्हेरी बेसिक कॉन्सेप्ट रिगार्डिंग द state machines, but actually now we are going to discuss about VLSI related applications where we are going to use this state machines. Okay, and here we have 2 types of state machines. One is the Mealy machine, okay, and another one that is the Moore machine. So these are the 2 types of machines that we are using. Okay, so here Mealy machine, that is characterized by outputs as a function of inputs and current state. Okay, so whatever is the current state of output, so on that this output will be dependent. Okay, so here you can see it is the next state logic that is dependent on the input as well as current state. Okay, and then it whatever is the output that will be stored in the state memory. So for that a flip flop may be used, and then we will get the output logic. So output will be dependent on the input as well as current state, and then you will get a current state. Okay, so this is the Mealy machine, while the Moore machine, that is characterized by output as a function of current state only. Okay, so here this output logic that depends on the current state only. It is not dependent on the input, but whatever is the current state, on that only it is dependent. Now this current state that depends on the inputs, but output logic or output is not dependent on the current state. Okay, so that is the major difference between the Mealy machine and Moore machine. Okay. So these both Mealy and Moore machines, these implementation that can be implemented with any sequential circuit. Okay. So why choose one element over the other? So we have to consider efficiency. So the next state logic that may differ significantly when using different flip-flops types. And the another one, that is the efficiency of implementation, that is also drastically affected by choice of the state assignment. So for depending on these, we need to select particular Mealy or Moore machine. Now let us have example of this Moore machine. So what is Moore machine? As I said earlier that this output is dependent on the input as well as the current state. Okay, so let us say that it has the current state that is a 0 0. Okay, so A, that is a present state, that is a 0 0, and the input X, that is 0. Okay, so now how the next state will be dependent on this inputs as well as the present state. Okay, so if X is equal to 0, it will go to the next state, that is a C, which is 1 0. Okay, and if b a is sorry, x is equal to 1 and a is equal to 0 0, so in that case next state will be b. Okay, now for this b, okay, state b, if x is 0, then it will remain in the same state, that is a b, and if x is equal to 1, then it will be in the next state, that is a c. Okay, so here you can see whenever this a is 0, okay, so the output here, whenever x is 0, it will go to the next state, that is a c, and when x is equal to 1, then it will be in the uh, state, that is a b. Now for this state, if x is equal to 0, it will remain in the same state, while for x is equal to 1, it will go to the next state, that is a c, where it will be 1 0. Okay, then if here again for the next state, if x is equal to 0, then it will return to the state, that is a b, and if x is equal to 1, then it will return to the state a. Okay, so that is 0 0 state. Okay, so in that way we will have the मॉडेल. ओके, ऑर दिस मुरे मशीन. म्हणजे इथे प्रत्येक वेळेला काय असणार आहे की तुमचे जे काही आउटपुट आहे ते कशावरती डिपेंडंट असणार आहे. म्हणजे इथे आता जेव्हा ए स्टेट मध्ये असणार आहे तेव्हा तुमचं आउटपुट हे 0 असेल. इफ इट इज इन अ बी, देन आउटपुट विल बी इक्वल टू 1 अँड फॉर द सी इट विल बी अगेन 0. ओके, so output is dependent on the current state as well as the input. Okay, so that is the Murray machine. And for the Mealy machine, it is dependent only on the current state. Okay, so suppose the current state, that is 0 0. Okay, so now if the input is 1, then it will be in a state C, or if it is in a input is 1, then it will be in a next state. Okay, so in this way here we will have the Mealy machine. Okay, so now let us have one example for this Mealy and Murray model. Okay, so we will have the example of D flip-flop here to represent a Mealy model as well as Murray model. Now as you know that in a D flip-flop, how output changes? So suppose that present state we are going to consider as a Q of t. Okay, input to flip flop, that is a D of t, and next state, that is a Q of t plus 1. Now whenever initial or the present state is equal to 0 and input is equal to 0, next state will be equal to 0. Whenever present state is 0 but the input to flip flop is 1, output is going to change, or the next state will be 1. Okay. Then if the previous present state is equal to 1, input to flip flop is 0, next state is going to be 0. If present state is 1, input to this flip flop, that is 1, then next state will be equal to 1. Okay, so now we will see how to represent this in a Mealy model. Okay. Now in a Mealy model, actually these states that are represented as an output. Okay, so these are the output states and that changes depending on the input and current state. So these nodes that are shown with the output. So here these are the two nodes. One is the output that is has the state that is a 0, and another one that is a 1. Okay, and this this shows, these arrows shows, or whatever written over there, that shows the input and the current state. Okay, so suppose that input is 0 and current state is 0, then output will remain in the state that is 0. Okay, so if the present state is 0, so this shows the output present state. म्हणजे हे इथं जे काही तुम्ही बघताय हे रिप्रेझेंटेशन काय आहे, तर तुमचं इनपुट काय आहे ऑब्लिक तुमचं करंट स्टेट मधलं आउटपुट काय आहे. ओके, त्याच्यावरून तुमची नेक्स्ट स्टेट डिसाइड होणार आहे. तर आता इथे जर तुमचं इनपुट 0 आहे आणि त्याच वेळेला तुमच्या करंट स्टेट मधलं आउटपुट पण 0 असेल तर तुमचा फ्लिप फ्लॉप हा त्याच स्टेट मध्ये राहील म्हणजे 0 स्टेट मध्ये राहील. ओके, सो दिस इज द नेक्स्ट आउटपुट स्टेट. Now, if output changes to 1, okay, sorry, input changes to 1. Okay, earlier it was 0. So, input changes to 1, then output will go to, and earlier output, present state output, that was 1. So, then it will change output to 1. Okay. Now current state output is 1 and input is also 1, that time it will remain in the same state. So that means here you can see if the current state input is 1, input to the flip flop is 1, it will have the next state as a 1 only. So that means it will remain in the same state. But if input is 0 and earlier state out input was 1, then it will go to the state that is a 0. Okay, so in this way this will be the Mealy model for D flip flop. Now the same flip flops that we can represent in the Murray model. Okay, so here now these nodes are shown with the input and output. Okay, and then what is the output state change that will be shown over. Now suppose we have the input that is 0 and current state is also 0, then output will be 0. Okay, if input changes to 1, okay, current state input is 1, then output will be 1. Okay, now if the current state input current state output is 1, input is 1, then it will remain in the same state, that means it will have the 1 output. But if input changes to 0, then it will go in this state that where the output is 0. So that is the Murray model for the D flip flop. Okay, so in this way we can represent any application in terms of Mealy machine or Moore machine. Okay, so we are going to discuss about this all in detail. We are going to discuss about some applications, that is a sequence detector, then coffee vending machine, traffic light controller in the next lectures. Okay, so for today we will stop here. Answer your roll call. Okay, roll number 1. Roll number 1, 2,
Present, ma'am.
3. Roll number 3, 4. Roll number 4,
Present, ma'am.
5,
Present, ma'am.
6,
Present.
7,
Present, ma'am.
8. Roll number 8, 9.
Madam, roll number 3.
Roll number 8, 9,
Present.
10,
Present, ma'am.
11,
Present, ma'am.
12. 12 आहे का? 13, 13, 14,
Present, ma'am.
15,
Present, ma'am.
16,
Present, ma'am.
17, 17, 18, 18,
Present,
19,
Present, ma'am.
Present.
20, 20, 21, 22,
Present.
23,
Present.
24,
Present.
25,
Present, ma'am.
26,
Present, ma'am.
27, 27, 28,
Present, ma'am.
29,
Present, ma'am.
30,
Present, ma'am.
31,
Present, ma'am.
32,
Present.
33,
Present, ma'am.
34,
Present.
35,
Present.
36, 36, 37, 37, 38, 38, 39, 40, 41,
Present.
42, 42,
Present.
43,
Present.
43, 44, 45, 46, 47, 48, 49, 50,
Present, ma'am.
51, 52, 53, 53, 54, 55, 56, 57,
Yes, ma'am.
58, 58,
Present.
59,
Present.
60,
Present.
61,
Present, ma'am.
62, 63, 64, 65,
Present.
66, 67,
Present, ma'am.
68, 68, 69.
Yes, ma'am.
So tell your friends that I'm going to consider this
Hello,
attendance
ma'am.
only. Yes.
Ma'am.
Huh?
18.
68.
18. Okay, I have considered it. 68. Okay. So tell your friends.
Madam,
Roll number 3. Yes, I have considered it. सो टेल युअर फ्रेंड्स. ओके, परत परत मी सांगते की तुमच्या फ्रेंड्सना सांगा की मी आता जो काही रोल कॉल करेन तोच अटेंडन्स कन्सिडर करणार आहे. मी रॅन्डमली कुठल्याही वेळेला तुमचा अटेंडन्स कॉल करेन. ठीक आहे, आज मी लास्ट घेतला पण मी काही सांगता येत नाही, मी मध्ये पण घेऊ शकते. सो बी प्रेझेंट इन अ क्लास, बी अटेंटिव्ह. मोबाईल कुठेही ठेवून तुम्ही बाहेर फिरू नका किंवा खिशात ठेवायचं आणि फिरायचं असं करू नका. ओके, कारण हे तुमच्यासाठी चाललं आहे, तुम्हीच याचा फायदा घ्यायचा आहे. जे काही चालू आहे ते बाहेर तुमचा बाहेरचा सिनारिओ तुम्ही बघताय, बाहेरचे इतक्या लोकांचे जॉब सध्या चाललेले आहेत आणि अशा कंडिशन मध्ये तुम्ही जर नवीन काही शिकलात आणि तुम्ही जर ऍक्टिव्ह राहिलात तर ते तुमच्यासाठी फायद्याचं आहे, म्हणून हे सगळं चालू आहे. ठीक आहे, तर अटेंड करा, सिन्सिअरली अटेंड करा. ओके, नॉट जस्ट अटेंड बट सिन्सिअरली अटेंड करा. ओके, so that this will be useful for you. Okay, so for today we will stop here. We will continue with the further in the next session. Okay, so till then, thank you. Okay, bye. You may leave this meeting.